EMV introduces new concepts and terminology, and in many cases, changes to cardholder behavior at the terminal. One topic that always generates a lot of questions is PIN change. Specifically, how does PIN change at the ATM work with EMV? Let's review the familiar magnetic stripe scenario. ATMs operate in an online-only environment. That is, the ATM does not authorize transactions, nor does it verify the PIN entered by the cardholder. Information is sent online to an issuer's host or authorization system for validation. In this presentation, we will use the word host to represent the issuer, or whoever is performing transaction authorization, PIN verification, and similar functions related to an ATM transaction. When a magnetic stripe card is presented at an ATM, the ATM reads data from the magnetic stripe. Then there is no further interaction between the card and the ATM. The ATM formats a transaction request and sends it to a host system. A transaction can be on us, that is, my card at my issuer's ATM, or not on us, my card at another institution's ATM, or another institution's card at my issuer's ATM. A transaction might therefore go through an acquirer and a network to reach the issuer's host system. The issuer authorizes the transaction and sends a response back to the ATM. Some card issuers allow their cardholders to change the PIN associated with their magnetic stripe card. In order to facilitate cardholder PIN change, there must be a PIN offset, PIN verification value, or PIN verification number associated with the card. In this presentation, we will use the term PIN offset to represent all of these PIN verification methods. The PIN offset can be stored in the track 2 of the magnetic stripe or on the host system. To facilitate PIN change at the ATM, the PIN offset must be stored on the host system. When a PIN change is performed, the PIN offset value stored on the host will be updated to reflect the new PIN. PIN change is an explicit transaction selection at the ATM. It is not combined with another transaction such as a cash withdrawal. The cardholder will select the PIN change transaction, enter their current PIN, and enter the new PIN twice to make sure they enter the same new PIN both times. The current PIN and the new PIN are encrypted, and the PIN blocks are sent to the host system. The host will verify the current PIN, generate the PIN offset for the new PIN, store that PIN offset, and generate a response to the ATM that confirms the success of the PIN change transaction. When the host is responsible for verifying the PIN, that PIN is known as the online PIN. Magnetic stripe cards and magnetic stripe-only ATMs cannot handle the new EMV cryptograms, nor can they handle issuer scripts from a host. Therefore, if you are supporting PIN change today for magnetic stripe cards, you will continue to use the same process going forward, business as usual, or BAU. In any of the combinations shown here, we're talking about the online PIN as it is used today. The way the online PIN is changed at the ATM remains the same even with the introduction of EMV. Some issuers offer other ways for their cardholders to change their PIN. A cardholder may be able to walk into a bank branch and use a hardware and software solution offered in the branch to change their PIN. It may also be possible for the cardholder to call and change their PIN through an IVR. In either case, the PIN offset on the host system is updated to reflect the new PIN. It's critical that the PIN stays in sync between what the cardholder thinks their PIN is, and therefore the PIN the cardholder enters for a transaction, and the PIN offset stored on the host system. Even with the introduction of EMV, ATMs still operate in an online-only environment. Transactions still go to the host for authorization, and the PIN must still be verified by the host. An online EMV ATM transaction request contains a cryptogram, which must be verified by the host. This is called the Card Authentication Method, or CAM. The diagram highlights some of the major steps of an EMV transaction. One new item that is of particular interest for a PIN change transaction is the issuer script. The issuer script is sent from the host as part of a transaction response when the issuer wants to update something in the chip. This allows the issuer to change something in the chip while the card is in the field. The cardholder does not have to bring their card into the branch, and the card does not have to be reissued. Only certain information can be modified this way. Each of the payment network's chip specifications, for example, M-Chip for MasterCard and VSDC for Visa, describe what can be updated in their applications through the use of an issuer script. The script and the commands it contains must conform to the Application Protocol Data Units, or APDU, command response format that is mandated by EMVCO and recognized by the chip, since the script is sent unaltered from the host to the chip, and the chip only recognizes commands in APDU format. The exact syntax of the script can be challenging for developers, since it's probably not familiar to them, and it can take some time to get it exactly right if you have to build your own issuer scripts. Issuer scripts are most commonly sent as part of a transaction response to an ATM, not to a point-of-sale device. Although there is no technical reason why a script could not be sent to a POS device, and some countries do this, there is a greater likelihood that a cardholder may remove the card prematurely from the POS device before the script can be delivered. At an ATM, the chip card is held by the chip card reader until the transaction is complete, so it is more likely that the script can be delivered to the chip. The cardholder verification method, or CVM, is the way in which you verify that the person using the card is the legitimate cardholder. The greatest benefit of EMV is that it reduces counterfeit fraud. In an online transaction, this is possible by verifying the cryptograms we saw earlier. If the host can verify the ARQC, it's clear that the transaction was initiated by a legitimate card, since only the card and the host have the key needed to generate and validate this cryptogram. But even if we are sure that the card itself is legitimate, that does not mean that the person using the card is the rightful cardholder. That's where the CVM comes in. As you can see from this chart, the only CVM that is allowed at the ATM is online PIN, where the PIN is entered by the cardholder, encrypted, and the encrypted PIN block is sent online to the host for verification. But with point of sale, other options are possible, depending on the way the card and the terminal are configured and what functions they support. Of particular importance to this discussion is the CVM called offline PIN. Each application in the chip may support more than one CVM, so there is a CVM list in the chip for each application to indicate which CVMs that application supports. The hierarchy of the CVMs may be based on business needs of the issuer. For example, which CVMs the issuer thinks will be used the most by the card. A chip-enabled POS terminal will also support a CVM list. The terminal will attempt to use the CVM that's highest in the list that is supported by both the terminal and the chip application. The only CVM that can be used to perform a transaction at an ATM is online PIN. If a chip card is presented at an ATM, but none of the applications on the card support online PIN, the transaction may still be able to proceed. There are networks where the ATM will ask the cardholder to enter a PIN anyway, outside of the EMV kernel. Offline PIN refers to the scenario where the PIN is stored in the chip and the application supports the CVM called offline PIN verification. The PIN is only stored in the chip when one or more applications on the chip card support offline PIN verification. Another way to say this is, the PIN is not stored in the chip unless one or more applications on the chip support offline PIN verification. So, for a chip card that does not support offline PIN verification, when PIN change is performed at an ATM, it's business as usual, just like for a magnetic stripe card, because you are changing the online PIN. In this case, The host should never send a PIN change or PIN unblock script to the card since there is no PIN in the chip. With offline PIN verification, the cardholder enters their PIN at the point-of-sale terminal and the PIN is verified offline, that is, between the chip card and the point-of-sale device. Because the PIN is not being sent online to the host for verification, what is the PIN entered by the cardholder verified against? The offline PIN stored in the chip. If a chip-enabled terminal reads the magnetic stripe and uses the first byte of the service code to determine that this is a chip card, and then reads the chip, the data in the magnetic stripe is not used for the transaction. This means that if the PIN offset is in the track 2 of the magnetic stripe, it will not be used, because the track 2 data can't be changed at the ATM. So there is really no point in putting the PIN offset in the magnetic stripe when you support offline PIN. Instead, the PIN offset must be stored on the host. This is used to verify the online PIN, whereas the PIN stored in the chip is used to verify the offline PIN. The PIN can be stored encrypted in the chip, or it can be stored in the clear in the chip because it is stored in a secure location within the chip. As with the private keys that are stored in the chip, the offline PIN cannot be seen by inserting the card in a chip card reader and dumping the contents of the chip, as many handy products will allow you to do. With the offline PIN CVM, the PIN entered by the cardholder is verified between the chip card and the chip-enabled POS terminal. In order to perform offline PIN verification, both the chip card application and the chip-enabled POS terminal must support it. Offline PIN verification is not mandated by EMVCO or the EMV specifications or by any of the major payment networks, but some regions or stakeholders within a region have elected to mandate offline PIN support at the point of sale. A good example is the French transit system. Their unattended kiosks will not accept magnetic stripe cards. If you use a chip card, it must support offline PIN. The PIN change issuer script is only used when a chip card is performing a PIN change at a chip-enabled terminal and the chip card supports offline PIN verification, so the PIN is stored in the chip. The purpose of the PIN change issuer script is to carry the command that the chip will execute to change the value of the offline PIN in the chip. The issuer script and its PIN change command is formatted by the host system and attached to the PIN change response. The script contains the new offline PIN encrypted. The chip must execute the PIN change command and store the new PIN in the chip. Let's look at an on-us example of a PIN change where the chip card contains an offline PIN and the chip-enabled ATM offers the PIN change selection. The cardholder selects the PIN change transaction at the ATM. When the transaction request reaches the host will verify the current PIN and update the PIN offset stored on the host. The host will also generate an issuer script containing the PIN change command, which will be attached to the transaction response. The ATM will pass the issuer script to the chip card, and the card will execute the command, which updates the offline PIN stored in the chip. When a chip card is used to initiate a PIN change transaction at a chip-enabled ATM, all of the steps listed here stay the same as in the scenario where a magnetic stripe card is used to initiate a PIN change transaction at a magnetic stripe ATM. So, what is different about a PIN change by a chip card at a chip-enabled ATM? Nothing, unless the chip supports offline PIN verification and the PIN is stored in the chip. In that case, the PIN change scenario must include some additional steps as shown here. The PIN must stay in sync between what the cardholder enters at the PIN pad and the PIN offset stored on the host system in order to verify the online PIN. If offline PIN is supported, then the offline PIN stored in the chip must stay in sync as well. There is a PIN change scenario that can be a challenge. When an ATM supports magnetic stripe and the PIN change transaction, A chip card is presented at this ATM, and the cardholder selects the PIN change transaction. If the chip card does not contain an offline PIN, the PIN change can be done for the online PIN, business as usual. But if the chip card does contain an offline PIN, the magnetic stripe ATM cannot pass an issuer script to the card, so the offline PIN in the chip cannot be updated. The ATM can tell by looking at the service code in the magnetic stripe that this is a chip card, but the ATM cannot tell if the chip contains an offline PIN or not. As an ATM owner, do you want to allow PIN change in this scenario? If so, you will pass the PIN change request to the issuer and hope that they will take the appropriate action. As an issuer, you will need to look at the transaction and determine if it was initiated by a chip card at an ATM that is not chip enabled. If so, you could allow the transaction to proceed if the card does not support offline PIN. But if the card does contain an offline PIN, you would want to decline this PIN change, since you cannot send a PIN change command to the card to update the offline PIN in the chip because the ATM cannot pass that issuer script to the card. You would end up with an out-of-sync condition. There are other scenarios where the PIN change command does not reach the chip or cannot be executed by the chip. This results in an out-of-sync condition because the cardholder assumes he is changing his PIN and the PIN offset on the host is changed, but the offline PIN in the chip is not changed. This results in an out-of-sync condition because the cardholder assumes he has changed his PIN and the PIN offset on the host system is changed, but the offline PIN in the chip is not changed. This out-of-sync condition must be corrected immediately in a manner that is transparent to the cardholder. If the chip card received the issuer script but the PIN change command was not executed, the chip will send an unsolicited status message to the ATM. The ATM must interrogate the information from the chip to determine the cause of the problem. If the PIN change script was not executed successfully, the ATM must generate a reversal to the host so the host can back out the new PIN offset. One challenge may be that the host may not store the previous PIN offset, only the current one. In this case, the reversal message must carry the previous PIN encrypted as well as the new PIN encrypted, so the host can revert back to the PIN offset for the previous PIN. The failure of the PIN change script to be executed is the only time when the host must be notified immediately of a script execution failure. If any other type of issuer script cannot be executed, this information is passed to the host with the next online transaction request. Offline PIN management is the process whereby the PIN is kept in sync between all of these components: the cardholder, the PIN offset on the host that is used for online PIN verification, and the offline PIN in the chip. For practical reasons, PIN change is usually not offered as a selection at a point-of-sale device. Technically, you could do a PIN change at a POS device if the device supported it, but merchants want to get customers through those checkout lanes as quickly as possible, and they would not want to offer a transaction that might take extra time and therefore hold up the line. And as we noted previously, there is the possibility that the cardholder will remove the card from the POS terminal before the script can be delivered to the chip. PIN change is therefore most often offered at the ATM for customer convenience. The ATM provides a way to change the offline PIN, even though offline PIN as a CVM is not possible for an ATM transaction. The ATM is just a conduit, passing the issuer script from the host to the chip to facilitate changing the offline PIN in the chip. The ATM does not interrogate issuer scripts. Impacts to issuers and ATM owners of supporting PIN change will be covered shortly. There are other ways to change the offline PIN in addition to offering the PIN change selection at the ATM. Some financial institutions will obtain a hardware and software solution that allows the cardholder to change their PIN in the branch. The solution basically sends a PIN change script to the card and ensures that the host system is updated with the matching PIN offset. In some regions, PIN change using an IVR is allowed, but only for the initial PIN change. The customer must then go to an ATM and do a transaction, which could be just a balance inquiry, in order for the PIN change script to be delivered to the card. Or the issuer could send the PIN change script to a POS device if that is where the card is used next. When PIN change is done using an IVR, the chip card is not physically present at a device that can update the offline PIN, so it is important to get the PIN change script to the chip as part of the next online transaction performed by the card. At this point, you may be wondering how other regions handle offline PIN management, and if it is even going to be used in the United States. There are differences between the U.S. payment system environment and that of other countries. This poses a challenge in several areas. In other regions, offline functions were common at the point of sale, so introducing more offline functions with EMV was not hard to accept. In the U.S., we operate in basically a 100% online environment for both ATM and point of sale, so introducing offline functions poses a bigger challenge here. Many other regions have had a central bank or a central program management office, or PMO, setting the direction for all stakeholders in the region. This resulted in a consistent implementation across the region. Therefore, cardholders had a consistent experience at every ATM and point-of-sale device. In the U.S., we do not have a central bank or PMO telling us what we have to do. The EMV Migration Forum can educate, suggest, and recommend, but it cannot force stakeholders to do anything, nor can it enforce its recommendations. Stakeholders have many implementation options, which may lead to different cardholder experiences. Some regions support chip and signature for credit. Other regions have adopted chip and PIN, including PIN for both debit and credit transactions. There are some pockets of resistance to introducing PIN with credit in the U.S. Other regions had fewer debit networks. In fact, in some areas, the banks own the ATMs, and there is a lot of in-network cooperation among financial institutions. Basically, there were fewer players and more cooperation due to PMO directives. In the U.S., we have many debit networks, and the amount of in-network or cross-network cooperation is not clear as far as how functions such as PIN change at the ATM will be offered. Let's take a quick look at what happened in the UK and in Canada. In the UK, PIN was virtually non-existent at the point of sale before the introduction of EMV. With the move to EMV, the region adopted chip and PIN for debit and credit transactions. Signature was phased out for cards issued in the UK, and in fact, there was an I Love PIN Day that marked the end of the use of signature as a CVM for UK-issued cards. Signature is still accepted at the point of sale for non-UK issued cards. Online PIN is used at the ATM, and offline PIN is the preferred CVM at point of sale. Using the Link network as an example, its members include stakeholders from all areas. Virtually every cash machine in the UK is connected to the Link network, and most Link members support PIN change at the ATM for other Link members. In Canada, a PIN has been used with debit cards since the 1980s. A PIN was typically provided with a credit card as well, but that PIN was only used when performing a cash advance at an ATM. It was not used at the point of sale. Signature was the popular CVM at point of sale. Canada implemented chip and PIN for debit and credit transactions. Online PIN is used at the ATM. Offline PIN is a preferred CVM at point of sale. PIN change can be offered in several ways. Banks typically allow PIN change at the ATM on us only. Credit unions that belong to the Acculink network allow their members to change their PIN at any ATM belonging to the Acculink network. The Canada Postal System, Canada Post, also offers a PIN change service through a third party, although this option may not be as popular with issuers and cardholders as the other options. When a region has no central bank or PMO dictating how to implement EMV, issuers and ATM owners are free to implement what makes sense to them from a business, financial, and technical perspective, as long as they abide by the rules of EMVCO and the payment networks with which they are associated. Let's look at some of the options for issuers first. As an issuer, do you even want to support offline PIN verification? Before you immediately decide either way, take a close look at how and where your chip cards will be used. For example, an issuer whose cardholders never travel outside the United States may take a different approach than an issuer with a large base of international travelers. If you decide to support offline PIN, will you do that for all card portfolios or just a subset? Here are some options you may wish to consider. Be aware that cards that must support offline PIN verification are likely to cost more than cards that do not support offline PIN. This is because the chip may require more memory in order to support additional data elements, and it may also require stronger cryptography and the keys and certificates that are required for public key infrastructure if you are using offline enciphered PIN. In order to pass certification, your chip cards will need to accept some basic issuer scripts whether you implement offline PIN verification or not. But you will have to rigorously test PIN change and PIN unblock scripts if you do support offline PIN. Although it is possible for each application on a chip card to use a unique PIN, cardholders would never understand having a separate PIN for each application on their chip card. So issuers will often configure their chip cards so that all of the applications on the chip use the same PIN. When you have a chip card with one or more applications that require a PIN, you may have to support both online PIN and offline PIN for the card. For example, the card can be used at an ATM with the online PIN being sent to the host for verification, which means the PIN offset must be stored on the host, and that same card could be used at a point-of-sale device that supports offline PIN, and the PIN entered by the cardholder is verified against the offline PIN stored in the chip. In this situation, the issuer must support offline PIN management in order to keep the PIN in sync. If you support offline PIN, you must provide at least one way for the cardholder to change their PIN. Where this can be done will depend on how convenient you want this to be for the customer. You may want to offer this only at your ATMs, that is, on us only, in network, but then which network, in your branches, or combinations of the above and other methods. You must also provide a way for the offline PIN to be reset or unblocked when the maximum offline PIN tries has been reached. What happens if the cardholder takes their chip card that supports offline PIN to a point-of-sale device that also supports offline PIN, and the cardholder enters their PIN incorrectly 3 times? If 3 is the maximum number of offline PIN tries allowed by the issuer, then the offline PIN is now considered blocked. Offline PIN verification cannot be performed until that PIN is unblocked. Most of the time, an issuer will configure the card so it can still be used, although another CVM, such as online PIN, must now be used. Typically what happens is that all of this is transparent to the cardholder. He tries the PIN the 4th time, and the transaction goes online to the host with the encrypted PIN block, and the host will try to verify the PIN. The online transaction request will contain an indication that the offline PIN tries have been exceeded. When the cardholder does enter the correct PIN, the issuer can send a PIN unblock script to the card, which will reset the offline PIN try counter. Offline PIN verification can once again be attempted. Be aware that the offline PIN tries is tracked in the chip, but the online PIN tries is still tracked on the host. I have seen a situation where a cardholder entered their PIN wrong 3 times at a POS device that supported offline PIN verification, Then the cardholder went to an ATM and entered their PIN wrong 3 times again. The issuer did not initially understand why the customer was allowed 6 bad PIN tries instead of just 3. It was a bit of an educational process to help them understand the difference between the online PIN tries and the offline PIN tries and why they are tracked separately. Can your authorization system handle basic EMV functions such as verifying the ARQC and generating the ARPC? If not, then supporting offline PIN management is probably not feasible for you. If you are planning to support basic EMV functions, make sure that your hardware security module has the necessary EMV extensions. To support offline PIN, this may require premium commands. Decide what will happen when your system is offline. If another party performs stand-in or on behalf of functions for you, do you want them to handle PIN change as well? Or will you only offer PIN change when your system is online? Implementing offline PIN is much more complex than supporting online PIN. You will have a longer project timeline and therefore a higher cost for your project. So why would you even consider supporting offline PIN verification? It really depends on your customer base and your business needs. If you have a lot of international travelers and you do not want them to be inconvenienced, offline PIN is a really good idea. You may be faced with implementing public key infrastructure for your cards at some point in the future, so you may want to bite the bullet now rather than later. Many EMV project managers have recommended that when you make the budget request for your EMV migration project, it's better to ask for everything up front. You may not get it all, but if you keep going back to the well for pieces and parts, upper management may get annoyed by that too. Offline PIN could be marketed in a positive way as long as you don't get too technical about it and confuse everybody. Now let's take a look at the ATM side of this issue. An ATM owner may decide not to support PIN change at all. If you do not offer it today, that is an easier decision than if you do offer it today, because it's typically not considered good practice to support a popular feature and take it away later. This is especially true if you are marketing chip cards as new, cutting edge, more secure, and so forth. If you offer PIN change at the ATM for magnetic stripe, you will most likely have to support it for chip. If you decide to implement PIN change at the ATM, decide what cards can perform this function at your ATMs. Will you offer this on us only, or only for certain networks? The PIN change feature can be marketed very positively. If you decide to support PIN change at the ATM and you have never offered this function before, here are some of the things you may have to do. Adding support for PIN change at the ATM will add time to your project. A lot of testing is required. You might want to consider implementing PIN change later, after you have implemented basic EMV functionality, complied with mandates and the liability shift, and you are comfortable with the technology and the data associated with EMV. As a network, you will have to pass issuer scripts as part of an EMV transaction response. The network will typically not care what type of script is being sent when the network is simply passing a transaction from one point to the next. If, as a network, you drive ATMs, you will be faced with many of the same decisions and tasks as any other ATM owner. In the grand scheme of things, when contemplating your EMV migration project, you really don't need to lose any sleep over PIN change at the ATM. There are many more important things you need to be focusing on before you get to PIN change. In my opinion, worrying about PIN change at the ATM is way down on the list of priority items, although your management may feel differently. I believe that offline PIN management is one of the most, if not the most, complex functions you will implement with EMV. When PIN change goes right, the blue sky sunny day on us scenario, it has plenty of moving parts, and it is enough of a challenge to get this working smoothly. But reversals add complexity, and when multiple parties are involved, there are many potential points of failure. A lot of testing is required. I cannot emphasize enough how important testing is to an EMV project, but especially when implementing a complex function such as offline PIN management. And of course, we don't have any consensus yet in the US about whether offline PIN is going to be widely used. But whatever we as an industry or you as an individual stakeholder decide, remember how important it is for the consumer to have a consistent and positive experience. Your EMV migration project can be a great success, but it also has many potential points of failure. With the immediacy of social media, the internet, and so forth, when a consumer has a bad experience, millions of people can be aware of it within minutes. Make wise decisions so your organization is not the target of bad publicity. Thank you for watching this presentation. We hope it has been helpful. Paragon Application Systems is a leading provider of e-payment simulation, configuration, and testing software solutions. We have over 590 customers in more than 85 countries. We offer professional services, including EMV training. Paragon has been accredited by MasterCard to provide EMV project guidance for MasterCard customers. For more information about our products and services, contact us using one of the links shown here.